Hey and welcome back to the channel. This is the first part of a four-part series on object-oriented programming, which is a great place to start when you've mastered or understood the basics of Python. How this guide is going to be structured is that I'm going to give you an explanation, and then I'm going to give you an example, and then I'm going to give you 3 exercise questions to try your knowledge. Let's begin with explanation. So up until now, if you're a beginner programmer, you've likely been writing procedural code. And procedural code is kind of what you're seeing here. You got your declarations, you made maybe some functions, and then you use the functions. It's executed step by step, and you don't make any strange stuff. This is what you normally do. So we have a list of your students, Alex, Bob, and Charlie. We have ages, grades, and then a print students function, which loops through the list and then prints out the grades. So let's try running this, and we get a nice little list of the name, age, and grade. This coding paradigm works great when you have small programs, smaller projects, and you don't really need many fancy things. But as the projects grow to medium or large size, then you might want to have connected data, and that kind of connected data benefits from more control and structure over that data. So object-oriented programming solves this by allowing you to create your own objects and classes. And what this means is basically you can create a data structure. And a data structure sounds really vague, but it basically contains 2 things. First, it contains your variables, your attributes. So here we have a class for student. A class is basically a blueprint for creating students. So down here, we have objects being created. This is the object Alice with these values, these attributes being created in the student class. We have 3 students being created. And it's this code right here that defines what every student contains. The class is the cookie cutter, and the students that are being created are the actual cookies. So when an object is created, it's given a name, an age, and a grade. And there's even a method here. And a method is a function which belongs to a class. So this function is specific to be run on student objects. And I'll show you how that works later. So what happens here is we create a list. We create a list of 3 different students. And then when we access the attributes of these students, we can just use the dot and then access the name, which is much more simple than accessing your students and then the length of the array, and like they're just combined. So student 0 dot name equals Anna. So now we're changing the name of the student, which is in position 0 in this array, which is Alice. We're changing it to Anna. And if we get a little print on this, we use this function for printing all of the students, and we see that the name Alice is changed to Anna. So this is the same output as before, but here we're organizing the data of the students and combining them with the functionality that we want to pair, that we want every student to be able to have. So I'm going to show you a full-scale example of this after going over the advantages of using the classes. So number 1 is that the student is a single unit. So as I mentioned before, every single attribute that's linked to a student is contained within the class. And every functionality that you want the student to have is also linked within the class, right here. Second, there's no need for indexing. Right now we're indexing on which student to right here, we're indexing on which student to look at, but not on anything else. Like here, we're like keeping track of the I and the index, and it's just very complex. Like we can access the name of any student just if we give proper reference to it. Third, it's much easier to understand. I believe this function, this for loop, is much easier to understand than this one. Here you have to keep track of the I and the in range for the length of your students. Like if we like mess up the length of one of these lists, like we're gonna run into trouble. It's just not very explainable, and it's very easy to lose track of. Like imagine we had 50 students instead of 3. With this method, kind of makes sense. And this is also much easier to understand. And the fourth, of course, is much easier to access the attributes of the objects. So here we just access the first student in this list, dot name, and it's equal to Anna. Or we can print the name or do whatever. But it's just very, very intuitive to just write dot name. So let's go ahead and look at a proper example. So this is an example of defining a car class. This might be useful if you're creating a game or you're making some kind of simulation and you want to have a unit, which is a car, and you want to decide what kind of attributes and things that it can do. So here we have an init function, which runs every time we create an object of the class car. And each object of the class car will have three attributes. Three attributes. One brand, one model, and one speed. And we also have two functions linked to the class, two methods. The first one is accelerate. So we're defining the method of acceleration. The self here, I'll explain in a later video. Basically, it's just referencing which object we're going to do it on. So the accelerate sets the speed of the object to plus equal to 10, which increases the speed by 10. And then it prints the brand model is now going at its new speed. We also have a similar function, which is break, which sets the speed of the object to the maximum of 0 and self dot speed minus 10. So this basically prevents it from going in a negative speed, which is possible. And then we have a print statement, which is the object's brand, object model slowed down to this new speed. So what we're doing here is we're linking the attributes and the functionality of this unit of class, the car. So what we can do with this is that we can define new cars. So this is the class, and here we just instantiated two objects. These are instances of the class. And an instance is basically just like how I made the cookie reference earlier, like the instantiation of the class. So we have car 1, which is car of Toyota and Corolla. It's the Toyota Corolla and it's going at 50 kilometers an hour. Car 2 is Tesla Model S and it's going at 70. And if we just run this code, nothing happens because we haven't printed anything yet. We can use methods to interact with the objects. So these methods can really be whatever you want them to be. But in this example, we have car accelerate and car brake. So now if we run car1.accelerate, car2.brake, so we should increase the speed of car 1, decrease the speed of car 2. Let's see what happens. So now we see Toyota Corolla is now going at 60 kilometers an hour. It was previously 50 plus 10. Makes sense. Car 2 got braked and went down to 60. Makes sense. And now if we comment out this code, oops, and do this little simple use case, we have a simulating a short drive with these two cars, and we have a little for loop that accelerates car 1 3 times and then brakes it 2 times. So after this, it should end up at plus 3 minus 2 at 60 kilometers an hour again. Let's have a look. Yeah, so it sped up to 80 and then it went down to 60. Right, makes sense. Now let's move on to the exercises. So I have 3 questions for you. Question 1 is, what will happen if you run the following code? And what I've done here is I've imported the car class from this file. So because they're in the same directory, if I have another file, that's also another benefit of classes. We can import them. So I don't have to define the car in this file. I can let them be in the example and then use them here. So that's what I'm doing with this statement. Question 1, what will happen if you run the following code? We have a car, it's a Honda Civic, it's running 40, we brake it 2 times. We reduce the speed by 10 2 times, we end up at 20. Oh, look, it's running our example code here. Let's just comment that out. There we go. Let's run again. And we see Honda Civic slow down to 20 kilometers an hour. Great. Now, question 2, do the different car instances affect each other? So if we create 3 cars, car 1, car 2, car 3, we have 3 different cars. And here the answer is that they do not affect each other. That's the great thing about objects is that you can create as many as you want and they don't affect each other. Just as you can create how many integers as you want or how many strings as you want, they don't affect each other. They just go by the same rules which you have defined in your class. Third question is, what will this code print? Let's see, we got a car, it's a Ford Mustang going 30 and we accelerate and it's going to be +10. So the Ford Mustang is now going at 40 kilometers an hour. Looks great. Right, this was the introductory part to object-oriented programming. I hope you got a little feel for what it is. And in the next video, I'm going to show you how to write your own classes and how to use objects in a more detailed manner. So thank you for watching and I'll see you in the next video.